So, will Earth's magnetic poles flip? Now, our scientists are saying that the pole flip will not happen after all. This is according to PNAS, and I'll leave a link below for you for this. Recurrent ancient geomagnetic field anomalies shed light on future evolution of our South Atlantic anomaly. Earth's magnetic field, which is generated through convection in the liquid iron-rich outer core, acts as a shield against harmful particle radiation, and during the past 2 centuries, the field strength has decreased rapidly as an area of weak field has expanded over the South Atlantic Ocean, and they don't know why this is going on. Now, the decreased shielding effect of the magnetic field in this area has important implications for low Earth orbiting satellites and space travel. Using archaeological and geological records, we have reconstructed, they say, the variation of Earth's magnetic field over the past 9,000 years. We find evidence for recurring magnetic field anomalies, similar to the present-day South Atlantic anomaly, which provides insights into underlying geodynamo processes that may help predict the future development of Earth's magnetic field. And their abstract says the strength of the geomagnetic field has decreased rapidly over the past 2 centuries, coinciding with an increased field asymmetry due to the growth of the South Atlantic anomaly. The underlying process caused the decrease are debated. They don't know why. They have no idea why this is going on. A decrease in the Earth's magnetic field, which has led to speculation that the field is about to reverse. Here we present a geomagnetic field model based on indirect observations over the past 9,000 years and identify potential ancient analogs. The model is constructed using a probabilistic approach that addresses problems with age uncertainties and smoothing of sedimentary data that have hampered previous attempts. We find evidence for recurring hemispheric field asymmetries related to quasi-periodic millennial scale variations in the dipole moment. Our reconstruction indicates that minima in the dipole moment tend to coincide with geomagnetic field anomalies similar to the South Atlantic anomalies, and we propose that the period around 600 BC, characterized by a strong asymmetric field, could provide an analog to the present-day field. The analogy implies that the South Atlantic anomaly will likely disappear in the next few hundred years, accompanied by a return to a more symmetric field configuration, possibly a strengthening of the axial dipole field. Now, what happened 600 BC? We don't know. I can't remember. Was there some kind of a super eruption or something? I don't know. Now, according to Science Alert, the planet's protective shield is not quite what it used to be, and over the past 2 centuries, the magnetic strength has taken a decrease. Nobody knows why. They haven't the foggiest idea. Now, the anomaly over the South Atlantic has blistered over the Atlantic Ocean, and lately they say it's also splitting in two. Both of these troubling observations fuel concerns that we might be seeing signs of an imminent reconfiguration that would turn the compass points topsy-turvy. But researchers, as we said before, based on the similarities and recreated anomalies, they said we predict the South Atlantic anomaly will probably disappear within the next 300 years and that Earth is not heading towards a polar reversal. This is what geologist Andreas Nilsson from Lund University in Sweden says. Not anytime soon, anyway. So, for our geological history, it's likely the flowing lines of our planetary magnetic field will eventually point the other way around. What such a reversal would mean for humanity is not clear. The last time a reversal happened, it was 42,000 years ago. Life on Earth seemed to go through a rough period as rain of high-speed charged particles ripped through our atmosphere. Whether we humans notice, perhaps responding by sending a bit more time sheltered, is a matter of speculation. Now, geologists are keen on how wobbles and wiggles and wanderings in the field herald catastrophe. Much of what we know of magnetic field history comes from the way of orientation forces particles in molten materials. You know, they say they see it from the rocks that they examine. Whatever has emerged from eruptions coming out of the earth locks into the rock the magnetic field of that time. That's how they know how old this was and where the compass was pointing. So then you studied the London University and Oregon State. We constructed the detailed timeline of our planet's magnetic shield, the shell stretching back towards the last ice age. So we have mapped, they said, changes in the Earth's magnetic field over the past 9,000 years, and anomalies like the one in the South Atlantic are probably recurring phenomena likely to correspond variations in strengths of Earth's magnetic field. So with thousands of years of perspective, it becomes clear the South Atlantic soft spot is not completely out of the ordinary. Starting around 1600 BC, similar geological changes took place, lasting some 1,300 years before evening out once again. Now, it's good that they say that they don't believe it will reverse, but again, they have no idea why this is happening. Why is the magnetic field of the Earth decreasing? And this is on Science Alert and PNAS, and I'll leave links below for you for this. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.